Yeah, I know Yi Ling's probably bigged me up a little, and I hope I live up to it. Or if she said, don't worry, it's going to be crap, you'll have to listen to him. Hopefully I'll do better than that. But I'm just going to get you all started with a nice cheesy bit of Lockheed propaganda.
100 years ago, there were 141 miles of paved roads in the U.S. The Eiffel Tower was the world's tallest building. Aircraft flew at 30 miles per hour, but not for long. In a rented Santa Ana church, a dreamer went to work, bringing an innovative aircraft design to life. And two mechanics started building seaplanes out of a San Francisco garage. These pioneers blazed a trail that would change aerospace and our lives forever. The companies they founded paved the way for a century of unprecedented change. But one thing has always been constant: commitment to continuously push the boundaries of technology and serve the cause of freedom and global security. A commitment embodied for 100 years by the men and women of Lockheed Martin. From World War to Cold War to War on Terror, from the industrial age to the information age, we've helped America and allied nations rise to the challenge of tomorrow. With breakthrough performance and game-changing innovations, we've continued our legacy of building revolutionary aircraft that have always given our forces a decisive edge. We help power the space race, furthering the reach of science and igniting the imaginations of generations. We put eyes in the sky to provide intelligence, monitor the environment, witness the birth of stars, and detect the faint echo of the Big Bang. We've innovated breakthrough technologies to train, protect, and equip frontline forces on the ground, in the air, and at sea. And we've harnessed the power of ones and zeros to serve ever-changing government missions. Today, as the very definition of global security expands, as governments seek to better serve the needs of citizens, the men and women of Lockheed Martin continue to answer the call. United by an unwavering sense of purpose, we're ready for the next mission. And the next. And the next. We know that the velocity of change will continue to be a challenge we will continue to embrace in our next 100 years of accelerating tomorrow.
Yeah, so anyway, I am talking about, obviously, software development in industry. I know that video seemed very American, but there is a few things in that video that are actually made in the UK. If you look at the big information room they had, that's actually our experimental war room we have based in Farnborough. Obviously I can't say too much about it, but it's a really awesome room. Literally, if I could have one of those computers, I would just never leave my room. Right, so yeah, I'm Tom, as I said before. Oh yeah, apologies for the awesome amount of animations. I love animations. Just going to talk for you who I am, who the company is, even though that video should hopefully give it away. And basically, the projects I worked on, and they're obviously going to be a little bit different from the case studies you've done or other presentations you've seen, because this is defense is very different from a standard kind of industry model. And obviously my experience at the end, and then hopefully pass on some knowledge to you. So, who I am, there's me, here's me. I'm finally a computer science student. That meant 2 years ago I was sitting where you guys, well I wasn't because I just said I wouldn't come to this. But I should have been sitting where you guys are sitting now. Yeah, so I'm computer science. Are you all computer science? Software engineering? Yeah. I had a year out, Lockheed Martin, the UK branch, which is based in Havant, Portsmouth, lovely area, weird people, nice shopping. And I worked as both a software engineer and a systems engineer. The main difference being software engineer, you're working literally programming, even though it's not a developer role. The big difference, and I'll get into that later. But even if you're scared of programming, I would still recommend trying software engineering. And then system engineering is the hardware side. So you're working with the networks, the radar systems, the acoustic systems, the infrared systems, which I'll get into later. And there's a picture of me in Yosemite National Park. That's just showing, like, just because you're a software engineer, you can still have a life. And you can still wear dodgy bandanas around your neck. The company, boom, that's the F-35, which is Lockheed Martin's baby at the moment. It's just replaced the F-22 Raptor. It's the fighter we're going to have on our aircraft carriers eventually. And it's hard to find anything Lockheed related that doesn't have that pictured all over it. So the company, it's a global aerospace, defense, security, and advanced technology company. Basically means we make lots of awesome things. And 130,000, it's a big company. It's the biggest defense company in the world. Now the thing about those 130,000 employees, it's, for the company it has like the largest number of scientists and engineers employed, percentage-wise, than other companies. Because obviously, and it comes down when you're working there. Well, I'm not a business person, but I now know a lot about business just because as an engineer, I was expected to find out how the business works and integrate with that business as part of my role. Again, I know we say it's a defense company. That's really a nice way of selling we make weapons. 74% of our revenue comes from military sales. And another interesting fact, every $1 in $15 the Pentagon spends goes to Lockheed Martin. So it kind of gives you the idea of how big this company is. Kind of like Tony Stark, Iron Man style. And yeah, so big thing, this is emerging as a massive competitor for the UK market, as in we're pushing BAE out the way. That's due to a number of things. It's one, the MOD has suddenly realised that, hey, we don't actually have to buy all of our stuff from BAE anymore. There's actually other companies out there. And that all comes down to how bidding for military projects works. And also, yeah, like I said, we now do, I don't know if any of you heard in the news, the Warrior program. Lockheed just won that. That's like a £2 billion contract. And then the MCSP, which I worked on, that's another huge project, and that's to upgrade all the Merlin helicopters. And we also do, everyone here has sent a letter, I'm assuming, or received a letter. And you know, in post, they use that automatic letter reading. We do all of that now. Like we entirely control Royal Mail's post, which could be considered a little bit worrying. And we also did the census, as there was lots of backlash about that. So the project, like I said, I worked on the Merlin helicopter, which is your multi-purpose big helicopter. They're like 18, I can't remember if it's feet or meters long, but they're very big. They're about the size of a Chinook, if anyone. This might be a better known helicopter. You could probably see in comparison to the troops on the ground. It's literally huge. And it's used by the Army, the Air Force, the Navy. It's got so many different uses. We were working on the Navy variant, and this is what we were working on in particular. This is the TMC, or Tactical Mission Computer, yes, which sits in the back, and basically it controls your radar, all that tactical system. That is exactly, if you walked into our test lab, you would have seen that without the pilots. So yeah, Merlin Capability Sustainment Program. Or it might be Merlin Capability Sustainment Plus, I can't remember. All I know is it's MCSP, definitely. It's our flagship project. It's a massive milestone. And it's basically upgrading the Mark I Merlin helicopters to the Mark II, and the Mark III and, yeah, Mark X, basically, it keeps going. And these helicopters are used on the back of a destroyer, Basically adds to its submarine hunting capabilities, its reconnaissance capabilities, all of that. And our upgrades were to the radar systems, which is your main detection and situational awareness. ESM, which I'm guessing you've never heard of, which are electronic support measures, which basically is the antennae part of a radar. You stick 4 of them to the corners of your helicopter, and then if someone else is trying to find you on your radar, you pick up that radar beam, and you can use some really complicated triangulation stuff to basically work out where that person is. And you can also then send energy back down and jam their radar. Acoustics. Now this is sonar, and as we all know, helicopters can't swim. So what it has is called a common acoustic processor, which is kind of the idea of the battlefield awareness, where you bring in everything into a place. And the Merlin will drop sonar buoys, they're called, little buoys that will send off your sonar waves. That information will then be fed back into the Merlin via radio signals, and then that will work out, if there's a submarine there. And then you've got FLIR, which is your forward-looking infrared, which is basically your target acquisition and identification. That's really secret stuff, so I'm not going to mention that again, in case I get shot. AMS is just your typical aircraft management system, fuel levels, autopilot, all that jazz. And then we also have the training systems, which is like the big motion simulators, classroom trainers, and then the more interesting stuff, like we have a mechanical system trainer, which is basically allows you to take a model of the Merlin to pieces and then put it back together. And that's all electronically controlled, so you can simulate faults. It's a way of training the mechanics. Right, the main project used an iterative waterfall cycle. I have a picture of that later. Written in Ada, IDL, Corbat, and other stuff. The code, this is a good software engineering example. It's also generated using case tools. So like Rational Rows or Star UML. Basically, you change that model, and then every night it will feed that data back into your programming code and change it. It was in the testing phase of its 3rd cycle. Right. If I just go back to how it was written, Corba and IDL are kind of a combination of how to make different modules of code talk to each other. So it's a database broker, basically. And IDL defines how that communication is going to work, and then Corba makes it happen. I don't know how it really works. I'd say it's black magic, and not many people know how Corba works because the book's about this thick, but it works. Now, Ada is a really important programming language if you are planning to go in real-time systems or in the defense industry. Someone asked me about this earlier today. Do you use Java real-time? If you said to an experienced software engineer, like I did when I was working there, you get laughed at a lot. Because Ada is what's called a statistically proven programming language. So you write a statistical formal proof on it, you code it, and then when your code is compiled, it can then be statistically proven that it won't fail. The problem with Java is because you have this whole JGC and this referencing, bits of your code can actually go missing, and if your navigation system goes missing and you're trying to fly a plane, plane tends to crash. So seriously, if you are planning to go on real-time systems, I would look into Ada. Bang. There's a picture of the life cycle. A really important phase at the start, this formal specification. That's kind of going back to the way Ada works, is you formally specify how you want it to work. Therefore, you don't get any hiccups. That's more for safety, really, because it's a safety-critical system. There you go in this constant cycle of design, implement, and test. Every time you're implementing, you're showing it, well, we're showing it to the Royal Navy, because they're our customer. And they're saying, I like this. This doesn't work. That works. And obviously, because it's a helicopter, you've also got flight trials and safety proofs. So you're making sure it's safe, and you're making sure it can actually be used in combat situations. We also have rigs on site, which we can test on. And then towards the end, that will go to acceptance and delivery, which is you go through your contract. Yes, you've done everything we want you to. Okay, next thing, the trainers. This is where I was. That big tree, which you might not be able to read because it's a really small font. We were in charge of basically the MPT, which is your HMI trainer. You're teaching the crew how to use the system. That was the main thing we were doing. But we were also in charge of the big dynamic trainer and the mechanical trainer I explained earlier. But we contracted them out. So because we own the contract for those pieces of kit, we can then say, hey, other companies, make this for us and create a subcontract of it. And a company in Canada actually did that, CAE. That's the main role of the subcontract manager. That's not really that important of a chart. It just showed it was a 8-man, 9-man, 10-man team, 8 software engineers, 2 system engineers. So, HMI trainer. We deliver the both training and the authoring stations, which is something I didn't think of. It's obviously a lot of simulator systems lately. Well, they're stopping it now, but they've been made with just pre-written lessons in them, so you can't change the lessons. Obviously, the MOD now wants to write its own lessons. So, training and authoring stations. It's designed just to teach the recruits how to use the system interface. That kind of gives you an idea of how complicated this interface was, that you needed an actual training system just to show someone how to use it. So it's basically an interactive manual. And it's got simulated tactical systems of the aircraft, but not necessarily like simulated complexly, just so if you've got a radar track, this is what you've got to do with it, not tactically what you should do with it. We use Scrum. This was written in Java, Ada, C, Callback, IDL, and SQL. So the Ada was the components from the actual main project. So we were making this training at the same time we were making the actual project. So it's been done in parallel. And that's good, because they both come out at the same time. So you haven't got a helicopter you don't know how to use, and you haven't got a training system for something you haven't got. But it also means it gives development a few issues. If there's a sudden change in the main project, then there's going to be a sudden change in your training system. That used Java purely because Java is great for making GUIs, and the training simulator isn't going to kill anyone. It's also used custom off-the-shelf hardware, some computers you can literally go and buy in the shop. Obviously, other than certain things like a radar controller, you can't go and buy that. But that also shows the way the industry's going. They want cheaper solutions from just custom off-the-shelf stuff. So you're getting a lot more companies that are just like system integrators rather than making the systems themselves. And we were in the development stage. I think when I was there, we went from increment 4 to 16, and then monthly increments. How the developments worked. Right. Like before, you have your formal specification. That always happens. These requirements agreed with system engineers, contract people, Royal Navy, obviously, and software engineers. The requirements are then broken down to these clauses that the software needs to do. And then these clauses are broken down into tasks. Now, because we were using Scrum, obviously we have to break that down into a burn down list even. And we use a program called ScrumWorks to do that, which is just a big cooperative, here's your list of tasks, tick them off, record progress. And all of our tasks had both a amount of effort required, which was man hours, and what's called feature points, which is how complicated, it's a measure of how complicated the task is with regards to how essential the task is. So if you've got something like, I don't know, the software to run videos, that'll have fairly high feature points because it's quite essential, but then it will fall down somewhere in the middle because it's not actually that complicated to implement. So basically, each increment has a set amount of either man-hours to meet or a set amount of feature points. Usually it was feature points because work does not expect you to sleep and they just want you to get these feature points to meet deadlines. Seriously, there's a metric that everything is based on, and ours was feature points. Yeah, so how the actual increments worked. We have a short planning session at the start of the increment, where well, I say short, it's 4 hours long. You all sit in an office for 4 hours, and you basically assign work to people. You know, how much do you think you can do? How long do you think it will take? And that's, yeah, that usually sets people rolling straight from there. Usually assigned an area. Like from the beginning, I was assigned to work on radar, so I was in charge of all the radar simulation. Tasks assigned to individuals, just said that. You have daily scrums, which stand up, say, hey, I did this today. No, I'm going to do this today. I did this yesterday. I'm having this problem. And they're just kept short, and then if they start to get out of hand, you say, look, email, talk about it later. And that's a great way for the team leader to keep track of where everyone is. And maybe if someone's having a problem with your system, you can say, hey, look, I can help you in this way because I know how this works. Code's reviewed every time you finish a piece of code. It's given to a team member who looks at it, reviews it, says, yeah, that's great. Can be made better if you do this. That's crap, get rid of that. That's wrong. And there's a demonstration and retrospective at the end, which is you show your end user, this is what we've done. And user's like, yeah, that's great, or usually, no, that's wrong, what are you doing? I want this. And then you have a retrospective, which is, what could you do better in your next increment? So, what is a software engineer? An organism that turns caffeine into source code. That is extremely true because I now have an addiction to Mountain Dew thanks to software engineering. But I did drink a lot of coffee. Caffeine is your new friend. But right, software engineering, I like to think, well, the people I work with certainly like to think there was a hierarchy of software roles. And something like web developer, just like, don't even get me started, they're scum. Then there's like developers who just code, they're all right. And then you have software engineers who we're the heroes, we do everything. Because basically these days you're going to see less and less job roles like system analyst, system architect. You're just going to see it all wrapped up in software engineer. And you might find out that actually you are a software engineer that specializes in a certain area, but you are expected to cover everything. That's why I said earlier, if you want to do, say, design of a system but you don't want to code, good luck finding a job, is what I'm going to say, unfortunately, because you will be expected to be able to do everything, even if you can't code very well. Yeah, analyze, you deal with requirements. You're expected to say, the customer wants this, this is how we're going to do it in software, and you're expected to also work out if that's plausible or not. Design, implement, and test new modules of software. That's your main role. Hence the engineering. You're not just going all Wild West and just writing random code in there. It's a very structured way of making developing code, but it works, and I don't know, it's fun, I suppose, maybe. No, not really. You're also expected to document new modules of software. Now, from those third years who have worked with me writing academically, will know that this has destroyed my ability to write academically. Because you're expected to write it really technically. You're aiming at other software developers. So it's when you deliver the system, they can take your piece of software to pieces and say, that's where it's broken, that's what we need to change. And know stuff. Now, that sounds really broad, but you are expected to, it's literally, imagine you work in an office full of your mum. Your mum is every other person that works there. They're expecting you to know everything about computers. Literally, every language. You will just be asked in half an hour notice, I need you to code something in this language you've never known before. You're also expected to maintain your own servers, your own software repository, update your own code onto your test rig. you're expected to know a lot. Google does become your new best friend, I'm not even going to lie. Just to go back to that, I should have mentioned this earlier. There's a thing called a software repository, which is like the main server that holds all your code. And yes, I have deleted the entire thing once by accident. But that is a key lesson. Do not code only when it's reviewed and tested is allowed to go in the software repository. And that's what that takes about 8 hours to compile. You leave that going overnight. And then you have working software in the morning, which you then plug into your test rig. All right. Is that right? Yep, yep, yep. Oh, okay, what's it like in an office? Okay, it's open plan, which means it's not in these films where you see you're stuck in a cubicle. I know maybe that's what some of you want because you hate people. But it's literally it's neck height with the boards. Everyone can talk to everyone. It means everyone can hear everything everyone else is saying, which isn't always good. Your management is in a separate office. That door is attached to your office, and it's open door. So it's basically your team's in one big room. So it's actually quite similar to when you're at uni and you're all stuck in one room trying to get work done, except you've been paid. Yeah, management in office has its plus and ups and downs. If you have a problem, you know exactly where they are. You go talk to them. If you do something wrong, they find out really, really quickly. And if someone's moaning that you glued their mouse to the desk, then they also find out really quickly. Metrics. Yeah, I hate metrics. Everything in a big company is based on metrics. Your daily reporting will be how many feature points have you done today, not have you made the code better, it's how many feature points. This is a double-ended sword. To the developers, it's the worst thing in the world because you're not actually focusing on how good you're making the software, you're focusing on trying to make certain bits of the software work, which can lead to quite badly coded software. But to management, it gives them an easy way of recording progress, which is actually something that's really hard to do on an agile project. And it's also really hard to plan an agile project, as we all found out. But metrics give you that way it's just that way of translating progress into something user-readable to non-computery people. You're sharing your office with other projects and departments. That's the main thing with that is because we're working closely to the main project, they're just a doorway away from us. So if we have a problem with something they've written, or we need to clarify something that they've written, we just go talk to them. What's up? Professional. You are expected to be maybe not all the time, but you're expected a professional appearance. Like if I was in work, I should be wearing trousers. And if there's an end customer in, you will be expected to do the whole suit, tie, drink with your pinky out, things like that. It's a very professional environment at times, but then it's also not that bad at times. I worked on what's a flexible 9 till 5 routine, which means you have 40 hours a week to do, and you have what's called core hours, which are hours where you have to be in work. So our core hours were 10 till 2. So we have to be in the office 10 till 2, except on Fridays when it's 10 till 12. So I don't have to come into work till 10, but then I obviously have to work later to make up for it. Or I can come in earlier, leave earlier. And come Friday, it means if you've done 36 hours in 4 days, on Friday you can leave at 12 if you come in at 8. That's good. That's good having a half day. It's also essential to survival. And in summertime, this company also runs, you do 40 hours in 4 days, which I know sounds horrific. You actually get your Fridays off, so you can have a 3-day weekend over summer, which is great. Yes, Johnny?
How early could you go in? Can you go in at, if you had problems sleeping, can you go in at 4 a.m.?
Our office was, we all had these special really secure ID cards and valve doors. So the office is open 24/7. You can go in at the weekend, you can go in at 2 in the morning, knock your socks off. I mean, I've done 70-hour weeks, so I've done 10 hours every day of the week, which is not fun, but it gets work done. But yeah, the way the company works is you record your own time, which might not always be the smartest idea, but it means you can just come in whenever. I really like the fact it was flexible. Yeah, everybody knows everybody in the office. So obviously, if you get you're the new person now, you just get people come sit on your desk, talk to you. You know, people in other offices. It's a lot more social than some people think. I got called, yeah, people knew me, the intern that breaks everything. The desk is your new home, literally. You decorate your desk however you want, as long as it's not like offensive. I had pictures and American football stuff everywhere, as well as lots of coffee, used coffee jars, and a pyramid of coffee cups. Coffee is the new alcohol. Now, what I mean by that is you're not just going to go, hey, let's all go to Starbucks, get absolutely slammed, get those espressos down us. You will find the new social way of talking to people at work is, hey, let's go for a coffee, and then you spend half an hour, go for a coffee, get paid to drink coffee, as long as your manager doesn't see you. Which is seriously, yeah. I mean, me and the guy I worked with, every morning we went for a coffee and just talked. I think that's quite good. And obviously you've got your diverse range of people, which you will be reminded of every waking minute because there's all these diversity posters everywhere. And our office actually had the chief of ethics in, so we got extra ethics and diversity, poisoning, propaganda. But yeah, everyone's different, and like, I know, like when I went in, I was quite close-minded to what people in an office would be like. I thought they were all going to be old men who wives are probably having affairs and they're broken down. But no, people are interested. People are very interested. I mean, sometimes, yeah, you have to spend half an hour talking about someone's conservatory or how their kitchen's broken or how the coolant's run out in their car. But no, my office was quite different. Especially if you're working with contractors, then you're going to find your contractors have a lot of experience. How many people think that's true? Can I have a show of hands? If that happens, I don't want to sound like a dick now, but if that happens, that's your own fault. Very rarely are you going to find in this modern environment that you're working in the same project, in the same job for 40 years. I mean, I used to have a guy who always said I got 40 more years of this, but no. The companies are very good with offering you new places you can work, new projects you can work on. This project only lasts about, well, it depends on the project, I suppose. But a lot of people go into what's called contracting, which is where you technically work for yourself, and then companies hire you to work on specific projects. It's a very new way of managing personnel on a project because you just hire personnel you want and then you can get rid of them when the project's gone. People get headhunted a lot more than I definitely realised. A lot of people will be asked, actually, can you work for us? And stuff like that. Especially in defence because it's a very niche market and you tend to learn techniques that other people don't know. I have a few of these. How many people think that one's true? If you let it, yes, you'll be contemplating suicide after 2 weeks. But no, if you blend in, it's a big change, obviously, working from uni life. But no, I liked it. I'm sure you'll all like it, hopefully. He's liking it, he's smiling. I probably shouldn't comment on this, but that's true. I'm not even going to lie. Yeah, let's move on. Yeah, days that'll be true as well, but try to hide it as best you can if you're sitting there doing nothing. But if you want to look really good, go ask for more work. That's what I have to say about that. Obviously, if you're sitting like that, your manager's going to go, what the hell are you doing? I mean, a good one we used to do is just, I shouldn't say this, just sit there, scroll the mouse up and down on a page of code. Looks like you're doing loads, but you've actually got Facebook in the corner. Yeah, social networking ruins your work life. No. Well, luckily, we weren't allowed it because the MOD doesn't like social networking on secure sites. But yes, avoid Facebook. Yeah, now, professionalism, like I said, you're expected to be professional when work needs to be done and when the end customer is around. That does not, however, mean that software engineering is boring. I'm just going to show you a few statements which may have happened, can't confirm or deny they're true, when I was in the office. There may have been a fire alarm system, which is infrared beams that go across the ceiling and pick up if there's smoke. Now, if a paper airplane goes through those beams, apparently the system thinks that's smoke, and apparently the fire alarm goes off. But I, of course, wouldn't know. Dominoes do deliver to your site. You have to let them in. When you have a 16-core Sun server in your test rig room, that plays Wolfenstein really well. Not that that's been done. Yeah. Yep, if you dislocate your kneecap playing American football, your team will not show you mercy when you come into work. They will hide your chair to begin with, and then tape up the elevator, so you have to use the stairs. Yep, I'm not a very good throw. This was fun, and then you'll always get someone that jumps into it. Obviously, like, your manager will turn a blind eye to this if you're getting the work done. But people, like I said, they are people in the office. I hope that one's not on video, because I probably shouldn't say that. But people may have put Pong in certain parts of software and maybe networked to other stations so you could have a networked Pong game. That's really fun if you don't fall off. Yeah, I did that. That gets you in trouble. It does when they pull it off and it takes part of the desk with it. That's fun. That's fun if other people don't use what you're doing. Do you all know what that is? Basically, you have a card of management terms like green sky thinking and I don't know what, postmodernism, that's an art term. But basically, sexy is apparently one as well. And you have to try and either, if someone says one of these terms, you tick it off. And you've also got to try and say your terms as well. It's quite fun. But make sure you know the people in the meeting. Don't do it in an end customer meeting because they won't be happy. I actually haven't done that. I'm not that stupid. Yeah, that was an accident. Yeah. A sonar station plays Hollywood Undead really well. So yeah. Yeah, this was one of my favorite quotes I had said to me. It was working before you fixed it. When you first start, you will make a lot of mistakes. Just don't worry, everyone. You will feel really stupid, but it's just industry software programming is completely different to university software programming. Yeah, prepare yourself for a steep learning curve. You're going to have a lot of information shoved down your throat straight away, because these systems are very complex and they do not use just one piece of software. They use about 6 pieces of software, all talking to each other. And like I said, if you come from, I know from my course, I'm not saying the course is bad, but me going into that real-time environment, everything's written in Ada, and they just go, here's an Ada program, and do this. I've never seen Ada before in my life. So the first thing you do is cry a little inside. And then just have a go. you got people, your team are actually very supportive. And my team were very good at understanding that hadn't even finished my uni degree yet. So I'm not that great. Be honest. The way we were working, occasionally a little bit of a blame culture came up, like, well, you changed this in the code, it's broken, it's your fault. You break something in the code, don't try and hide it. They will find out. They have a log of everything that's been changed. Just be honest. And that also implies if you don't know something, tell someone you don't know it. They're expecting you to know everything, but they're also expecting you not to. So if you don't say you don't know something, they're going to assume you do know it. So yeah, just be honest. Make friends, else you're going to find work is really unenjoyable. Just like people, like I said, they're people. Just go talk to them. Tell them about what you did at the weekend, even though they might not want to know. Next one, kind of above. Software deadlines are indeed met at 3 p.m. on a Sunday the night before. That does not change from university. You will still be in on, well, if you're a good teammate, you'll be on a weekend. I mean, this comes down to being young, where we haven't really got that many commitments. It doesn't really matter if you're doing extra hours. You get paid overtime, which is, overtime's a lot, that's all I'm going to say. Like 4 times your normal wage. A lot. Obviously, there's the employability. You learn skills uni can't teach, because uni obviously can't afford a Merlin helicopter. Though they can afford a Harrier, apparently. You learn how to talk to professionals, and deal with end users, which is something as well uni can't teach. That's something you're only going to learn from actually doing it. Familiarity with what it's like to work. I mean, I was waking up some days at 5:30 in the morning. I'd never dream of doing that here. And you don't get home till like 8, and then you just eat and go to bed. You definitely appreciate your weekends more when you're working, unless you're doing 70-hour weeks. Which I'm not saying don't do that as standard, else you will want to die. Just do it when it needs to be done. You understand how business works. Now, the third years will back me up here when I say how much of a dick I am in Yuling's lecture and correct her on how business works. But you actually learn things you don't actually realise at university can be a factor. Yeah, it's hard to explain. But like I said, being that engineer in a business environment, you do pick up on business. Learn added technical skills. Like I now know Ada, IDL, Corba, all of that jazz. All stuff I didn't know before uni. And that can all go on your CV. And employees like it when you know more than just one programming language. Especially since Java isn't actually used that much in industry. Even though you guys do C++. It's still not used that much. Sorry, uni. But it's, yeah, they're object-orientated is still kind of new in the industry, which I know sounds weird because it's been around for ages, but you're still working off legacy systems. So the original Merlin stuff was all grayscale, black and white stuff written in Fortran. Oh yeah, get a job offer. This might not happen, it happened to me. The company will go, hey, you actually know what you're doing. Even if you do glue mouses to tables and set off fire alarms, have a job. And in this environment, that's really a really good thing to have. Perks, discounted Starbucks. 60% off Starbucks. Bang. Invitation to company events. Now this is actually, obviously depends on the company, but because we were in aviation and defense, we get to go to air shows, which is great. You help out an air show and you get almost VIP tickets to that air show for free, which is brilliant. Formal dinners. Wow is all I have to say. I went to my first formal dinner at Lockheed and Jesus, there's free wine, so I was absolutely wheelbarrowed by the end of it. But the food is amazing. The whole atmosphere is amazing. It's literally in the films where everyone's dancing around in the ballroom. And there's all these posh foods on skewers and stuff. It's awesome. You just have to put up with some boring speeches about where the company's going. Charity events, there's a good side and a bad side. Bad side being, you know, uses up your time. Good side being they're quite fun. Like we had a dragon boat race. I found out I can't swim very well and I fall out a dragon boat. But then I also did stuff like go help out at a local school at an engineering day, where some little bastard will do you in with a soldering iron. But that's actually quite fun. Then the company runs, I can't even remember what it's called anymore, but they run a system where you're expected to do certain charity events. As you've got to make the time up yourself, which can be a bit of a pain, but seriously, it's good fun and you put it on your CV. And there was obviously other stuff like charity. We used to play, a big one was, it's almost like Coventry Warwick. We used to have Lockheed and BAE, we'd go play cricket against each other. There were never any fights like Coventry Warwick, but there's still the rivalry. Possibility to travel to different sites. I got to travel down to, God, what's it called? It's in Caldrose, RNAS Seahawk or something stupid like that. That is the Merlin base down in Cornwall, which is a really fun site to be in with extra time because there's, actually I can't say that, just trust me, it's really fun. And when you go down, you get all your expenses paid and you get a company credit card, so it's not even the money has to come out of your account, you just use this credit card as long as it's within the company's guideline. Like obviously, you can't go into a strip club and go, here's a company card. That would probably get you fired. But we stayed in a 4-star hotel. I've never been in a 4-star hotel before, and we stayed in a 4-star hotel and the company paid for it. And then we had like just free food every day. You just use your card and you pay at a restaurant. That's a definite perk. Exposure to industry and military standard technology. This is the nerdy perk. That is cool. Like, I've never seen a missile face-to-face before. I've never seen radar face-to-face before. And industry stuff, like I said, 16-core process, whatever it's called, a server. Who's ever played with a 16-core server before? I hadn't before, but A, they're really noisy, which is a little bit annoying, but they're so powerful, it's awesome. This is also, you're having exposure to this technology. It means you're learning technology that other people might not know. Like I could take apart a radar and put it together now because I've learned how a radar unit works. I know all this radar equation, how to pick up certain tracks, and how to work out a cross-section, and how ISAR and SAR work, and all this other radar stuff. I love radar, really do. Yeah, you get paid. 90% pork sausages. Average intern wage is 15k. I was on a little bit more than that. Graduate wage, looking about 25k for software engineer. And that you can expect that to go up in the 1 to 2 years to about 40k. Professional wage, yeah, 40. Some people in my office are on 150k a year. I mean, they're 10 times as much as the average intern. It's unbelievable. And they're doing the same amount of work as you. Makes you a little bit angry, but obviously they've earned it. But that's why I'm saying software engineering, you know, 150k a year, yes please. Oh, what's next? The future. Don't be afraid of different industries. Like, obviously there's a chance to work in pharmaceutical, motor cars, defense, other industries, boating, shipping, anything. You find all of these industries have their own like thing that's interesting to them because there's problems that are unique to that industry and they have a unique solution to, which is usually quite cool. Don't expect an easy ride. Enjoy it anyway. You can't just expect to walk into one of these really big paid jobs. You're going to have to earn it. And at times that will not be easy and you will feel like giving up, but trust me, don't. It's usually, you enjoy the good side, either side of the bad part. And it's if you, yeah, it's not that bad of a ride, but you're going to have to work for it. Like, you seriously, especially in this day and age of the recession, you really need to get a good degree and try and add some little bit extras onto your CV. Invest in yourself. Seriously, now, this is going to sound really cheesy, but the one constant you have in your life is yourself. You need to seriously go out there and find out what you want to do, what you enjoy doing, what you can bring to a team, and how you can bring that to a team. And, I mean, yeah, I think that's one of the most important things is actually, you leave uni, yeah, there's about, good luck, there's about 20,000 other applicants with your degree. You leave uni and you can bring a unique skill set to a job. That's what's going to make you stand out. Or if you've had unique experience, that's what's going to make you stand out. And last of all, I can't actually say that because it's Latin. I don't know how to pronounce Latin. Seize the moment. Seize the moment.
That's the day.
Seize the day. Oh, wait, no. That's my really awesome ending animation that's been ruined now. Seize the day, or seize the moment, as I'm going to say now. That's what else you can take it as. Great opportunities are born from great moments. Like I said, if you see an opportunity, you've got to go and take it. Even if it's just in one of these Scrum planning meetings and someone goes, well, we need someone to do this technology that no one here knows how to do, which is how I ended up doing all this radar stuff is. I just said, okay, I'll give it a go. And yeah, I think the moment you need to be confident in maybe taking that leap into the unknown. I mean, you might learn to regret it later, but 90% of the time, if you put the effort in, it'll pay off. I guarantee you. Okay, now, awesome animation. Thank you for your time. Any questions? And that's my email if anyone has anything they want to ask me via email. Thank you.